Hello everyone, I'm Sonic and I'm going to solve this standard max algorithm for LP simplex method. So we have this is our case. Caroline Cosmetic sells sets of starter makeup kits. Basic set consists of set A. The basic set will be our set A, and the set B, our set B will be the regular set, and then the set C is the deluxe set. And let's make our Z as our profit. The factory has on hand 800 face powder, 400 lipsticks, and 200 eyeshadows. Assuming all sets can be sold, being the company's head of OR, I am tasked to submit a memo to the marketing manager on the most optimal decision. All right, so sorry. So step two, as we are already declared our variables, set A, set B, set C, and Z, we're going to move into step two, formulate and rewrite the objective function. So our objective functions is our set A they had the company has 30 pesos profit. On the regular set is 40 and the deluxe set is 60 on profit. Okay, so this is put this in here, negative 30, negative 40, negative 60, and Z is equals profit. So for step 3, we're going to formulate the constraints. Okay, so the constraints is um constraints has two face powder, the lip two face powder, and three on the deluxes there are three face powder, and it cannot go beyond 800 face powder. And same for lipstick, 1111, and eyeshadow for 011. Let's put our slack here, S1, S2, and S2. So let's move on for the develop the augmented matrix. Okay, so we're going to copy this from the set A and set B. 210 and their profit 30. 2111 cancel. Okay, so 211 negative 40 and negative 60. And just copy this S1, S2, and S3 here. So we're going to what do you call this? We have determined the step 5 is the loop in pivot until the original constraint are non-negative. Okay, so as you can see here, we have a negative in here, and we are going to determine our pivot column with by the biggest negative, non-negative. So as you can see, the biggest negative here is the negative 60. And we're going to determine the pivot row as the biggest positive on the ratio. We got the ratio by dividing its what do you call this? Constraints. So as you can see here, we just copied it here to 800, 400, 200. We can see here that we divide it into the C in the pivot column. So 800 divided by 3, as you can see, it resulted 266.7. And same as here, and so on, so on. Now, next, perform row operations will becomes 1, perform row becomes 0, okay? So as you can see here, we still have negative here. So we're going to move on into our first iteration. We got this by getting the D17, the augmented matrix, as you can see here. First row, and we times it to its bottom 0, and then we added it to B17 here, and added itself So we just dragged itself to here. And then, what's the next? Perform row operation so the the pivot column becomes 0. Right, as you can see, we still have negative here in our pivot column. We're going to move into our second iteration. So negative 30, B20, B23. B26, where's the B26? Here. So as you can see, it is on the fourth column, fourth box, and we're going to start here. So we are going to put what do you call this? This dollar sign. I forgot what it's called. Um then times it to the B29 and add it to the B26. So here, the B26. And then we're just going to drag this. Don't forget to put negative sign in here. Oops, my bad. Okay. What happened? All right, there you go. We're going to drag it over here, and we can see we we are tasked to calculate the results with the objective function. The objective function is, so as you can see here, the profit we have over here is 15,000. We're going to put here 15,000 on our profit.